Hello Year 8, it's lesson 5, forces, waves and generating electricity. I did say that we'd mark this homework, so let's have a go at that. Homework 2, forces. The thrust, that's C. Friction forces, that'll be air resistance and the friction between the underside of the snail and the ground, that'll be F. The weight force, that's B. And weight is in a pair with this force here. A is the lift or reaction force, so that is A. Which two forces will be balanced if the snail accelerates? That'll be force B, weight, and the reaction force or lift, A. And finally, which two forces will be unbalanced if the snail accelerates? If the snail accelerates, his forward force will be larger than all the friction forces, F. There's your answers, 8 out of 8 there. Now, we're going to go on to an ICT opportunity. You'll be using the right-hand page that's turned around 90 degrees. And it's got these headings on it. Basic friction. So basic friction. Let's go through these now. Whenever an object moves against another object, it feels frictional forces. Friction makes it more difficult for things to move. You can find this information out on the internet. Okay, let's have a look at useful friction forces. The friction between our shoes and the floor to stop us slipping. The friction between tyres and the road to stop us skidding. The friction between the brakes and the wheel helps cars and bikes to slow down. Friction forces are much smaller on smooth surfaces than on rough surfaces. So of course we will slide on ice, but not so much on concrete. Unhelpful friction forces. If you've got a skateboard or a bike, you need to oil it regularly. Otherwise, the friction in the chain and the axle will increase and it will be more difficult to pedal. Think about car engines as well. They need oil to allow the rods and the pistons to move round inside an old style engine. If you didn't have the oil, the engine would seize up. Weird friction. When there's a lot of friction between moving parts, kinetic energy is transferred into other types of energy like sound and heat. Think of what happens when you rub your hands together and one hand surface rubs over the other. Weird friction. Then we've got air resistance. Bikes, cars and other moving objects, when they move through the air, they smash into billions of air particles. These slow the object down. Think about water when you swim, or the fish and the likes. When they move through the water, there's going to be water resistance. Now think about it. The particles in water are much closer together than they are in air. So water resistance tends to be much higher than air resistance. For example, if you were to try and run through water, you wouldn't be very fast. And the final thing is streamlining. Racing cyclists crouch down over their bikes to reduce the air resistance. They allow the air to flow over them. So do skiers and motorcyclists. They crouch down. They also can wear helmets that have special smooth shapes in order for the air to glide over them more easily. Why do you think Olympic swimmers shave the hair off their body? It's to allow them, and wear a cap as well, it's to allow them to be more aerodynamic, to be more streamlined. Modern vehicles tend to be streamlined as well. Some of the sports cars look almost like darts, almost like bullets. Obviously, the more streamlined they are, the easier it is to cut through the air. And of course, what's that impact going to have on their miles per gallon, or how far they can go on a charge? Anyway, it's over to you. ICT opportunity, internet research on friction, using some of the points as the reference points. Have a go at a double-sided A4 sheet or pamphlet, and don't forget to sign it as well. Anyway, that's the end of lesson 5 today. Good luck.